Hello and welcome to Lucid Mind Chemistry channel with Majid. In this video, I'll be solving Chemistry A-Levels Multiple Choice Paper 12 from October-November 2018. You can go to any particular question by following timestamps given in the video description. Let's start.
Question 1. Which statement about enthalpy changes is correct? Part A. Enthalpy changes of atomization are always negative. In atomization, element is converted into individual atoms, and this can happen only when energy is absorbed and intermolecular forces or bonds are overcome. Therefore, enthalpy changes of atomization is always positive as it is endothermic process. So A is incorrect. Part B. Enthalpy changes of combustion are always positive. This is also incorrect because whenever combustion takes place, heat energy is also released. It is always exothermic reaction, and enthalpy change should be negative. Part C. Enthalpy changes of formation are always positive. What happens in formation is that some compound is formed from its elements in their standard states, and whenever a compound is formed, it means the forces of attraction develop or the bonds develop. So whenever bonds are formed, the process is exothermic. So bond formation is always exothermic as energy is released. Part D. Enthalpy changes of neutralization are always negative. In neutralization, acid and alkali, they react together to form salt and water. The reaction produces heat, so therefore enthalpy changes of neutralization is always negative as it is exothermic reaction. Correct answer is therefore D. Question 2. Beams of charged particles are deflected by an electrical field. The angle of deflection of particle is proportional to its charge to mass ratio. In an experiment, protons are deflected by an angle of plus 15 degrees. In another experiment under identical conditions, H2 negative ions are deflected by an angle of y degrees. What is the value of y? In the question, the angle of deflection of protons is given. So for protons, we can write angle is 15 degrees, which is directly proportional to charge to mass ratio. So we can write angle is directly proportional to charge to mass ratio, where E is the charge and M is the mass. Now angle is 15 degrees and it is proportional to charge of proton, which is plus 1, and mass of proton is also 1. So 15 degrees is proportional to 1 for proton. Now doing the same for this, we have 2H minus, the proton number is 1. Again, angle is directly proportional to charge to mass ratio. Angle is to be found. Charge on this is minus 1 and mass is equal to the nucleon number, which is 2. So we can write angle is directly proportional to charge to mass ratio, which comes equal to 0.5 negative. Now we can equate these two to find the angle required. So we have angle on one side and charge to mass ratio on the other side. When angle is 15 degrees, the charge to mass ratio is equal to 1. And when angle is x, the charge to mass ratio is equal to minus 0.5. Now by cross multiplying, we can find the value of x. X equals 15 degrees into minus 0.5, which is equal to minus 7.5 degrees. So this shows the angle of deflection by H minus. The answer is therefore B. Question 3. Rubidium and bromine form ions that are isoelectronic. Isoelectronic means they have same electrons present. Each ion has 36 electrons. Which row is correct? First thing is the radii of rubidium when it is atom and when it is ion, and second thing is the radii of bromine when it is atom and when it is ion. Now rubidium is in group 1 of the periodic table. So it has 1 electron in its outermost shell and it is in period 5 of the periodic table, so it has 5 shells. Now when rubidium forms positive ion, it loses 1 electron that was present in the outermost shell. So in rubidium plus 1, 1 shell is lost. The inner shell is already complete. So it means that the size of rubidium will decrease when it forms ion as 1 shell is lost. So atom is greater than ion. Similarly for bromine and bromide, bromine is in group 7 of the periodic table. It consists of 7 electrons in its outermost shell and it is in period 4. When forming ion, bromine gains an electron to form Br negative, in which we have 8 electrons in the outer shell. Due to addition of a new electron, the electronic repulsion increases, so therefore the size of ion also increases. So we can say that bromide radii is greater than bromine atomic radii. The number of shell does not change in bromine and bromide, only the inter-electronic repulsion increase. That's why negative ion is larger than neutral atom. Answer is therefore C. Question 4. In which set do all the molecules have all their atoms arranged in one plane? Now you should remember that molecules that are linear, trigonal, and having bent structures are always in one plane. In bent structure we have an example of water. In trigonal we have example of BF3. In linear we have example of CO2. Other than these given structures, the atoms are not arranged in one plane. For example, in first one A we have PH3. Phosphorus is in group 5 of the periodic table. It has 5 electrons. 3 electrons are involved in bonding with 3 hydrogen atoms. So this is not trigonal, it is trigonal pyramidal. And atoms are not arranged in one plane, so therefore A is incorrect. Similarly, in example B we have NH3. Nitrogen also belongs to group 5 of the periodic table. It has 5 electrons in outermost shell, out of which 3 electrons form single covalent bond with 3 hydrogen atoms. And again the structure is same, it is trigonal pyramidal. And atoms are not arranged in one plane, so therefore this is also incorrect. In C we have C3H6, which is alkene. We have 3 carbon atoms, 6 hydrogen atoms. Now as we can see that this carbon is making 4 single covalent bonds and the bond angle is 109. So the structure is tetrahedral. All the atoms are not in one plane, so therefore this is also incorrect. In part D we have C2H4. We have 2 carbon atoms, 4 hydrogen atoms. Now we can see that the central atom carbon is bonded to 3 different atoms, so therefore the structure is trigonal. All the atoms lie in one plane. In CO2, we have carbon that makes double covalent bond with both oxygen atoms. Now the structure is linear as it is straight, and all 3 atoms are present in one single plane. Similarly, in H2O, we have oxygen that is bonded to 2 hydrogen atoms and 2 lone pairs are also present. The structure is bent structure, and all these 3 atoms are present in one single plane. Correct answer is therefore D. Question 5. Flask X contains 5 decimeter cube of helium at 12 kilopascals pressure, and flask Y contains 10 decimeter cube of neon at 6 kilopascals pressure. If the flasks are connected at constant temperature, what is the final pressure? According to Boyle's law, pressure is inversely proportional to volume at constant temperature. So we can say PV is equal to constant at constant temperature. For helium, the pressure is 12 kilopascals. We can take the pressure as P1 and the volume is V1. Similarly, for neon, we can take the pressure as P2 and volume as V2. Now, when both these flasks are connected, then the pressure will be P3 and volume will become V3. So we can write P1 V1 plus P2 V2. When connected, it forms P3 V3, where P3 is the final pressure and V3 is the final volume. Now putting values, P1 is 12 kilopascals and V1 is 5 decimeter cube, so it is 60. P2 is 6 kilopascals and volume is 10 decimeter cube, so again it comes equal to 60. So 60 plus 60 will be equal to 120. So if P3 into V3 equals 120, we have the total volume. Total volume is 5 decimeter cube plus 10 decimeter cube. It will be equal to 15 decimeter cube. So P3 into 15 decimeter cube equals 120. Or P3 equals 120 divided by 15, which comes equal to 8 kilopascals. So this is the final pressure when both flasks are combined. Answer is therefore A. Question number 6. Exactly 1 grams of metallic element reacts completely with 300 centimeter cube of oxygen at 298 Kelvin and 1 atmosphere pressure to form an oxide which contains O-2 ions. The volume of 1 mole of gas at this temperature and pressure is 24 decimeter cube. This is constant. What could be the identity of the metal? In options, we have calcium, magnesium, potassium and sodium. Now calcium and magnesium both belong to group 2 of the periodic table. So they will make an oxide MO, where M is metal and O is oxygen. While C and D belong to group 1 of the periodic table and they will make oxide of M2O, where M can be potassium or sodium. We can write balanced equation for both group 1 and group 2. For group 2, it will be metal plus oxygen. It forms metal oxide. For group 1, it will be metal plus oxygen, forms metal oxide. Now we can balance these equations. We can write 2 with MO to balance oxygen and 2 with metal to balance metal. Similarly, on this side, we can write 2 to balance oxygen and 4 with metal to balance metal. This is for group 2 and this is for group 1. In the question, we have 300 centimeter cube of oxygen which can be converted into moles. Number of moles is equal to volume in centimeter cube divided by 24,000 centimeter cube. So the number of moles of oxygen come equal to 0.0125 moles. Now in balanced equation, we can see that 2 moles of metal require 1 mole of oxygen for complete combustion. So 0.0125 moles of oxygen will require X moles of metal. By cross multiplying, we can find the value of X. So for group 2, 0.0250 moles are required for complete combustion. Similarly, for group 1, we can see in balanced equation 4 moles of metal require 1 mole of oxygen for complete combustion. So 0.0125 moles of oxygen will require X moles of metal. By cross multiplying, we can find the value of X. So for group 1, the number of moles come equal to 0.05 moles. Now we can find the masses of these metals by using atomic mass. For calcium it is 40.1. For magnesium it is 24.3. For potassium it is 39.1. And for sodium it is 23.0. So by using formula mass is equal to moles into atomic mass, we can find the mass of calcium. Number of moles is 0.0250 into its atomic mass, which is 40.1. So the mass of calcium comes equal to 1 grams. This is exactly similar to the one given in the question, so therefore A could be the correct option. Similarly, we can find the mass of magnesium. Number of moles is 0.0250. Atomic mass of magnesium is 24.3. So the mass in grams for magnesium comes equal to 0.607 grams. This is incorrect because it is not equal to 1 grams. Now for group 1 element we have potassium and sodium. For potassium we can find the mass. Number of moles is 0.05. Atomic mass is 39.1. Now mass in grams come equal to 1.95 grams. Again, this is not equal to 1, it is incorrect. Now for sodium, which is the last one, number of moles is equal to 0.05 into its atomic mass, which is 23. Mass in grams come equal to 1.15 grams. Only the mass of calcium come equal to the one given in the question, so therefore answer is A. Question 7. Ethanol is increasingly being used as a fuel for cars. The standard enthalpy change of formation of carbon dioxide is given. It is minus 393. Standard enthalpy change of formation of water is also given. Similarly, ethanol is given. What is the standard enthalpy change of combustion of ethanol? We can apply Hess's law. The formula of ethanol is CH3CH2OH. It can combust in the presence of oxygen to form carbon dioxide and water. Now the elements that are required for the formation of these reactants is carbon, hydrogen and oxygen. These elements can combine to form these reactants, and these elements can also form this product directly. Now this is a two-stage process and this is one-step process. We can write this one as delta H1, this one as delta H2, and this is given as enthalpy change of combustion, so this is delta Hc. Let's balance this equation. We have 2 carbon atoms on the reactant side, so we can write 2 with CO2. Similarly, we have 6 hydrogen atoms on the reactant side, so we can write 3 with H2O. Now in delta H1 we can see that 1 mole of ethanol is formed. Now the enthalpy change of formation of ethanol is minus 277. So for 1 mole it will be minus 277 kilojoules per mole. Now in delta H2 we have 2 moles of carbon dioxide being formed. Now the enthalpy change of carbon dioxide is minus 393. So it will be minus 393 into 2. It comes equal to minus 786 kilojoules per mole for carbon dioxide. Now for water, 3 moles are formed, so therefore we are going to multiply minus 286 with 3. It comes equal to minus 858 kilojoules per mole. Now combining these two, we can add them together and the answer is minus 1644 kilojoules per mole. Now by applying Hess's law, we can write the equation delta H1 plus delta Hc. As these are two steps involved, it equals to delta H2. We are going to find enthalpy change of combustion. The value of delta H1 is minus 277. So we can write minus 277 plus delta Hc equals minus 1644. Or delta Hc equals minus 1644 plus 277. Now the enthalpy change of combustion comes equal to minus 1367 kilojoules per mole. Answer is therefore B. Question 8. Ammonium metavanadate NH4VO3 can be used to make a solution containing VO2Cl which contain chloride ions. What is the change in oxidation number of vanadium in this reaction? We can find the oxidation states of vanadium in both these compounds. In first compound we have NH4VO3. In second compound we have VO2Cl. Now we know that the charge on ammonium ion is +1. Then we have vanadium. And on one oxygen, the oxidation state is -2. So for 3 oxygen, it will be equal to -6. Overall charge is 0. So vanadium -5 equals 0, or vanadium is equal to +5. Similarly, in this compound, we can find the oxidation state of vanadium. We have 2 oxygens, so it will be -4. 1 chlorine, so it will be -1. Overall charge is 0. Again, the oxidation state is similar, it is +5. So from +5 to +5, there is no change in oxidation number, so it is 0. Answer is therefore B. Question 9. In this question, all pressures are measured in atmosphere. The equation represents the equilibrium between 3 gaseous substances X, Y and Z. X plus 3Y comes equal to 2Z at equilibrium. At temperature T1, the numerical value of Kp, the equilibrium constant, is 2. At higher temperature T2, the partial pressure at equilibrium are shown. X is 2, Y is 3 and Z is 5. Which row is correct? First, you have to find out the numerical value of Kp at temperature T2. And second, you have to find out whether the reaction is exo or endo. Now we can find the value of Kp at equilibrium for temperature T2. The formula of Kp is equal to partial pressure of product, which is Z raised to the power is number of moles. As we have 2 moles, divided by the pressure of X multiplied by the partial pressure of Y raised to the power is number of moles. Now putting values, the value of Z is given as 5, so it will be 5 square divided by 2 into 3 cube. So it comes equal to 25 divided by 54. So it is either C or D. Now at temperature T1, the value of equilibrium constant Kp was equal to 2, while at T2, the value of Kp is 25 divided by 54, which is equal to 0.46. Now the value of Kp depends on the partial pressure of product, which is Z Now as T2 is greater than T1, so we can say that at higher temperature the value of Kp has decreased. It means that the reaction was exothermic. Because for exothermic reaction, whenever the temperature is increased, the equilibrium moves in the backward direction, so therefore the partial pressure of product will decrease, so therefore this is exothermic. Correct answer is therefore D. Question 10. In a chemical system, the particles involved have a range of energies. This can be shown on a graph called Boltzmann distribution. Which statement correctly explains the effect of catalyst on the particles in a chemical system? Now for catalyst, we know that catalyst always lower activation energy. Particle energy of the molecule is not affected by catalysts. Part A. A catalyst enables particles with a lower energy to collide successfully. Now as catalyst decreases activation energy, it means now the particles having lower energy can also convert into product. So this is true statement. Part B. A catalyst increases the number of particles with higher energies. Now catalyst cannot change the energy of particles, it means it cannot increase the number of particles having higher energy, so this is incorrect. C. A catalyst increases the number of particles with the most probable energy value. Again we can say that the particle energy is not affected by catalyst. Part D. A catalyst increases the value of most probable particle energy. Again this is incorrect because particle energy is not affected by catalyst. Only activation energy of reaction is lowered. Correct answer is therefore A. Question 11. Nitrogen and hydrogen can react together to form ammonia. The formation of ammonia is exothermic reaction. The rate and yield of the reaction can be altered by changing the conditions under which reaction is carried out, which shows the effects of adding iron to the mixture and increasing the temperature. First one is addition of iron and second is the increase in temperature. As iron is used as catalyst, so it will lower the activation energy. Part A, it has no effect on the equilibrium yield. This is true because catalyst does not increase or decrease the yield, it only increases the rate of reaction in both forward and backward directions. Part B increases the equilibrium yield. No. Part C increases the equilibrium yield. Again, it is incorrect because it does not have any effect on the equilibrium yield. D increases the rate of chemical reaction. Now as the reaction is exothermic, so therefore increasing the temperature will decrease the yield of product. So it reduces the equilibrium yield of ammonia. This is correct. Increases the equilibrium yield. This is incorrect. Increases the rate of chemical reaction. This is true as kinetic energy is increased. And last one is that it has no effect on the equilibrium yield. This is untrue because this is exothermic reaction and the reaction will move in backward direction. Correct answer is therefore A. Question 12. The melting points of period 3 elements phosphorus to argon are shown in table. We have 317, 392, 172, 84. Which factor explains the changes in melting point from phosphorus to argon? Now melting point always depends on the intermolecular forces of attraction. It does not depend on the type of bonding within the molecule, because in melting point the intermolecular forces are broken. Actually the bonds are not broken. Now we know that phosphorus exists as a molecule of 4 atoms in the form of P4, while sulfur can exist in a molecule of 8 atoms as S8. Chlorine exists in diatomic molecule as Cl2. And argon is always monoatomic. So we can say that greater the number of atoms present in a molecule, stronger will be the intermolecular forces of attraction. Therefore sulfur has highest melting point. And as argon is singular monoatomic, so therefore its melting point will be lowest. A. The changes in electronegativity from phosphorus to argon. As we are studying the molecules of similar atoms, so therefore electronegativity does not have anything to do with intermolecular forces. Part B. The changes in first ionization energy from phosphorus to argon. This is also incorrect because first ionization energy does not have anything to do with the intermolecular forces. Part C. The increase in number of electrons in each atom from phosphorus to argon. This is true statement because number of protons increase and number of electrons also increase. But this statement does not define the melting points because for melting point we are not studying individual atoms, we are studying molecules. So this is incorrect. Part D. The number of atoms in each molecule of the element from phosphorus to argon. As we can see that the number of atom increase, so melting point also increases. S8 has the highest melting point, then we have P4, then Cl2 and then argon. So this statement seems to be correct. Answer is therefore D. Question 13. Which observations are made when a sample of silicon chloride is added to a beaker of water? When silicon chloride is added to water, what happens that a chemical reaction takes place? And silicon dioxide along with HCl is formed. Now silicon dioxide is off-white precipitate. And white fumes of HCl are formed. A. No visible changes observed. This is untrue. B. Steamy fumes and a precipitate both are observed. This is a true statement. C. The appearance of precipitate is the only observation. No, this is not the only observation. We also have white fumes of HCl. D. The appearance of steamy fumes is the only observation. Again, this is incorrect because off-white precipitate is also formed. Correct answer is therefore B. Question 14. A 4 grams sample of anhydrous group 2 metal nitrate is heated strongly until there is no further change. A solid residue of mass 1.37 grams is formed. Which metal is present? In given options we have barium, calcium, magnesium and strontium. So as all of them are from group 2, so we can write the balanced equation for group 2 metal nitrate decomposition. So metal nitrate of group 2 is MnO3 2. It decomposes to form metal oxide along with nitrogen dioxide and oxygen gas. We can balance this equation by writing 2 and 4 with NO2. According to the question, a solid residue of mass 1.37 grams is formed and NO2 is a gas, oxygen is a gas. Only solid residue is metal oxide, so its mass is given as 1.37 grams. The mass of sample is given as 4.00 grams. So it is the mass of metal nitrate that is used. Now as the number of moles in balanced equation are equal, the number of moles in this mass should also be equal for the correct answer. For first one we have barium and barium forms barium nitrate. The molecular mass of barium nitrate is 137.3, which is the atomic mass of barium. Plus we have 2 nitrate whose atomic mass come equal to 124. So it is equal to 261.3 as molecular mass. Now we can find the number of moles by dividing mass divided by molecular mass. So it is 4 divided by 261.3, which is equal to 0.0153 moles. Now finding the number of moles of metal oxide for barium nitrate, the oxide formed would be barium oxide. Barium is 137.3 and oxygen is 16. It comes equal to 153.3 molecular mass. Now we can find the number of moles by dividing this mass divided by molecular mass. So 1.37 divided by 153.3. The number of moles come equal to 0.0089 moles. Now as from balanced equation, the number of moles should be equal. 2 moles of metal nitrate forms 2 moles of metal oxide. So now we have different number of moles, so therefore this is incorrect. Now doing the same for calcium. For calcium we have calcium nitrate. The molecular mass for calcium is 40.1 plus for nitrate we have 2 nitrates, so the molecular mass is 124. So it equals to 164.1. Now we can find the number of moles by dividing 4 grams with 164.1. It is equal to 0.0244 moles. Now doing the same for calcium oxide, which is the product. Calcium is 40.1, oxygen is 16, so it is 56.1. Now finding the number of moles, 1.37 grams divided by 56.1. The number of moles come equal to 0.0244 moles. As in the balanced equation, the number of moles are equal, and we also have equal number of moles for calcium. So therefore calcium could be the correct option. Similarly, we have magnesium and strontium. For magnesium, we can find the molecular mass. Magnesium nitrate, it is 24.3 plus 124, which come equal to 148.3. Now finding the number of moles, mass in grams, which is 4 divided by 148.3. The number of moles come equal to 0.0269 moles. Now for magnesium oxide, we have 24.3 plus 16 for oxygen. It comes equal to 40.3. Now we can find the number of moles, 1.37 grams divided by 40.3. It comes equal to 0.0339 moles. As we can see that the moles are not equal, so therefore C is incorrect. Doing the same for D, we have strontium nitrate. Molecular mass of strontium nitrate come equal to 211.6, and the number of moles is 4 divided by 211.6, which is 0.0189 moles. Similarly for strontium oxide, the molecular mass is 103.6. Now we can find the number of moles, 1.37 grams divided by 103.6. Number of moles come equal to 0.01322 moles. So again, number of moles are not same, so therefore D is also wrong. Correct answer is therefore B. Question 15. In which row or all statements comparing magnesium and barium are correct? First is the fourth ionization energy, and second is the reaction with water. Now magnesium and barium are in same group of the periodic table, in which magnesium is on top and barium is at bottom. So as we move down the group, size of atom increases. So therefore ionization energy decreases. As it is easy to remove an electron from a larger atom as compared to smaller atom, so therefore the ionization energy of barium will be lower than magnesium. Second thing is reactivity with water. As we move down in the group, the reactivity of group 2 metals increase. So barium is more reactive with water as compared to magnesium, so therefore barium reaction will be faster and magnesium will be slower. Correct answer is therefore B. Question 16, which statement about halogens is correct? A. Iodine cannot behave as an oxidizing agent. This is incorrect statement because halogens can gain electron to get itself reduced and they do behave as oxidizing agents. Part B, the volatility of the elements increases from chlorine to iodine. This is incorrect because volatility decreases because chlorine is gas and iodine is solid. So iodine is less volatile than chlorine. C, when an equimolar mixture of chlorine and hydrogen is exploded, only one product is formed. Let's write the balanced equation. We have 1 mole of hydrogen that reacts with 1 mole of chlorine. It can form 2 moles of HCl. That is the only product that is formed. So C could be correct option. Part D, when concentrated sulfuric acid is added to solid sodium bromide, hydrogen sulfide is one of the products. We can write the chemical equation. Sulfuric acid concentrated. It reacts with sodium bromide to form sodium hydrogen sulfate along with hydrogen bromide. HBr can be further oxidized by this concentrated sulfuric acid in a second chemical equation to form bromine, sulfur dioxide and water. As we can see that in the products formed, no hydrogen sulfide is formed, so therefore D is wrong. Correct answer is therefore C. Question 17. Chlorine reacts with both hot and cold sodium hydroxide to form products containing chlorine. Cold sodium hydroxide forms sodium chlorate X and hot sodium hydroxide forms sodium chlorate Y. X and Y are oxidation numbers. Which equation is correct? Now we know that with cold and hot sodium hydroxide the reaction is like this. With cold sodium hydroxide, chlorine forms sodium chloride, NaClO and water. With hot sodium hydroxide, chlorine forms sodium chloride, NaClO3 and water. We can find the oxidation state of chlorine in both NaClO and NaClO3. Sodium is +1, oxygen is -2, overall charge is 0. So the oxidation state of chlorine is +1 and this is sodium chlorate X. Then we have sodium chlorate Y. Sodium is +1, chlorine is Cl, we have 3 oxygen atoms. Overall charge is 0. So the oxidation state on chlorine is +5 in sodium chlorate Y. So we can say that X equals +1, Y equals +5. So we can say that +5 equals +1 +4. So C seems to be the correct option. Question 18. The product of contact process is Z. Which reaction or process leads to the formation of gas that can neutralize in an aqueous solution of Z? Now the product of contact process is H2SO4, which is sulfuric acid. And we need a gas that can neutralize this acid, so the gas must be basic in nature because aqueous solution of Z would be acidic. First one is atmospheric lightning. It can produce nitrogen oxide, which is acidic as it is non-metal oxide gas, so it is incorrect. B is the combustion of fuel in an internal combustion engine. It produces carbon dioxide gas. Again, carbon dioxide is acidic in nature. C is the Haber's process. In Haber's process, ammonia is formed and ammonia is basic in nature. So it can neutralize sulfuric acid to form ammonium sulfate. In part D, we have thermal decomposition of group 2 nitrates. So group 2 nitrate, for example, metal nitrate of group 2 would form metal oxide along with NO2 gas and oxygen gas. Now oxygen gas is neutral, it cannot neutralize sulfuric acid. NO2 gas is acidic in nature, it can also not neutralize sulfuric acid. Correct answer is therefore C. Question 19. If ammonium cyanate is heated in the absence of air, the only product of reaction is urea. CONH2 No other product are formed in the reaction. What is the formula of cyanate ion present in ammonium cyanate? We have two compounds, one is CONH2 and second is ammonium cyanate. Now we know the formula of ammonium, but we do not know the formula of cyanate, so we can find it out. Ammonium is +1. As we can see that only one product is formed, no other products are formed, so therefore number of atoms should be same. In CONH2 we have 1 carbon, 1 oxygen, 2 nitrogens and 4 hydrogen atoms, while in ammonium we have 1 nitrogen, 4 hydrogens and charge is +1. There is no charge on this compound. As the number of atoms in both reactant and product is same, so we have 2 nitrogen and 1 nitrogen is left. We had 4 hydrogens formed, so 0 hydrogen is left. We have 1 carbon left and 1 oxygen. So we have carbon, oxygen, nitrogen. These 3 are left behind. Now this could be the formula of cyanate. As the charge on ammonium is +1, so therefore the charge on cyanate must be -1 in order to make overall charge as 0. So we can see in the given options, the only one having -1 charge is OC and negative, and it has 1 carbon, 1 oxygen and 1 nitrogen. So therefore answer is C. Question 20. There are 3 structural isomers with the formula C5H12. This is alkane. Which formula correctly represent these 3 structural isomers? In A, we have 5 carbon atoms in long chain. Rest of the hydrogen atoms, there are 5 carbon, 12 hydrogens. Then we have 4 carbon atoms in the long chain and 1 carbon is present on second carbon as a substituent. Again, we have 5 carbon atom and 12 hydrogens. So this is structural isomer. Then we have this compound which is in such a way that this carbon makes 4 single bonds with 4 CH3. So this is also a possible structural isomer as the formula is same, C5H12. So A could be the correct option. Now in part B, we have 5 carbon atoms in the long chain. The formula is C5H12. Structure will be like this. Then we have 5 carbon atoms and 1 carbon is in the form of branch as the long chain consists of 4 carbon atoms. This is also correct structural formula. In the third one, again we have 5 carbon atom and this carbon is present as a substituent on this carbon atom. So the formula is C5H12. Now we can see that these two are similar. This is because numbering starts from the carbon atom having the least number given to the substituent. So this is 2-methyl butane. And in this compound we are going to start numbering from this carbon as the substituent has the least number. So again this is 2-methyl butane. So as these two compounds are similar, they are not structural isomers. Then in part C we have skeletal formula. 5 carbon atoms. As it is alkane, so the formula is C5H12. Then we have 4 carbon atoms in the long chain, and on second carbon we have methyl functional group. So again the molecular formula is C5H12. And in the third one again we have 4 carbon atoms in the long chain and substituent is present on second carbon. So both these are the same compounds, they are not isomers. This is 2-methyl butane, this is also 2-methyl butane. In part D we have substituent on second carbon. Then again we have substituent CH3 on second carbon. So both these are actually same, both are 2-methyl butane. So therefore D is also incorrect. The only option in which all three are different structural isomers is A. Question 21. The diagram shows a molecule that has sigma bonds and pi bonds. How many sigma bonds are present in this molecule? Every single bond is sigma bond, and in double bond we have 1 sigma and 1 pi. Let's draw all the bonds. We have first carbon atom. It consists of 2 hydrogens. Then we have sigma bond and carbon, then hydrogen. Then sigma bond carbon with 2 hydrogens. Then sigma bond carbon with oxygen. I'm only drawing sigma bonds right now. Now this is first pi bond. This is second pi bond. And this is third pi bond. We can count sigma bonds 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So we have 18 sigma bonds present in this molecule. Question 22. Polyethene is made by polymerization of ethene. Which statement is correct? In ethene we have 2 carbon atoms and 4 hydrogen atoms. In polyethene we have this repeat unit that is present. Part A, the monomer and the polymer have different empirical formula. Now we have 2 carbon atoms and 4 hydrogen atoms in monomer. We also have 2 carbon and 4 hydrogen atoms in the polymer, so the empirical formula for both is same, which is CH2. So statement A is incorrect. Part B, the monomer can be oxidized without heat, whereas the polymer cannot. This is a true statement because alkene can be oxidized by cold acidified potassium manganate, while the polymer cannot be oxidized without combustion. Part C, the monomer can be used as a fuel, whereas the polymer cannot. Now the monomer can be combusted to form carbon dioxide and water, The polymer can also be combusted to form carbon dioxide and water, so therefore this statement is wrong. Part D, the monomer has greater van der Waals forces than the polymer. This is incorrect because van der Waals forces depend on the number of atoms, as the chain in polymer are very long as compared to the monomer, so therefore van der Waals forces in the polymer must be greater as compared to this monomer. Correct answer is therefore B. Question 23. Compound P reacts separately with potassium hydroxide aqueous and HBr. This is compound P. What are the mechanisms of these two reactions? First is the addition of potassium hydroxide aqueous and second is HBr addition. Let's draw the structure of compound P. We have CH2. Then we have CH. It means double bond is present. Then we have CH2, CH2, Cl. So in this compound we have halogen, we also have alkene double bond present. Now KOH aqueous, it supplies OH negative, which is a nucleophile, and as chlorine has partial negative charge because it is more electronegative, and carbon has partial positive charge, so this OH will attack this carbon atom and this bond will be broken. So as this OH negative will replace this chlorine, so this is nucleophilic substitution because OH is a nucleophile. So it is substitution. Second is the addition of HBr. Now this double bond actually repels the electron present. So therefore hydrogen becomes partial positive, bromine becomes partial negative, and this bond is broken. Then this hydrogen is attached with the first carbon atom. Now we have 3. And this bromine will be attached to second carbon atom. So it will become CH3 CHBr. As H positive is electrophile and it adds up in alkene along with bromine, therefore the reaction is electrophilic addition. Correct answer is therefore C. Question 24. Which statement about compound Q is correct? This is compound Q. We have ester, we have alkene. A, it could be polymerized to give polymer with repeat unit this one. Now polymerization will occur upon double bond, so as this is alkene, so addition polymerization will occur, and on first carbon atom we have CH3 and CO2 CH3, while on second carbon atom we have hydrogen and CH2 CH3. So on first carbon we have CH3 and CO2 CH3, so this is incorrect. Part B, it reacts with chlorine by a free radical mechanism to give this product. Now in free radical mechanism, chlorine radical is present which will react with all the hydrogens present in the molecule, so no hydrogen will be left behind. As all hydrogen will become HCl and chlorine radical will form Cl. For example, when we have methane CH4, it can react with chlorine free radicals in a free radical mechanism, and all 4 hydrogen are replaced by chlorine in the end product. So this is incorrect. Part C, it reacts with cold dilute acidified manganate to give this product. In cold dilute acidified manganate, alkene is converted into diol. In diol, each carbon atom having double bond makes a bond with OH. So OH is attached on this first carbon atom and OH is attached with this second carbon atom having double bond. Rest of the structure is similar: CH3, CO2 CH3, hydrogen and CH2 CH3. So C is correct. Part D, it reacts with bromine via a free radical mechanism to give this product. Again, in free radical mechanism, bromine will replace all the hydrogen atoms, so no hydrogen atom will be left behind, so therefore this is wrong. The only correct answer is C. Question 25. A halogenoalkane has the molecular formula C5H11Br. The halogenoalkane does not form an alkene when treated with ethanolic sodium hydroxide. What could be the halogenoalkane? We can draw the structures of each compound given. A is 1-bromo-2-methyl-butane, as it is butane, so we have 4 carbon atoms in the long chain. On first carbon atom we have bromine, and on second carbon atom we have methyl functional group. Rest are the hydrogen atoms. The molecular formula is C5H11Br. Now in this compound, elimination can occur. From one carbon atom, halogen is removed, while from second adjacent carbon atom, hydrogen will be removed and alkene is formed. So A is wrong. B is 2-bromo-2-methyl-butane. So we have 4 carbon atoms in the long chain, as it is butane. On second carbon we have bromine and also methyl group. Again the molecular formula is same, C5H11Br. Elimination will occur and this carbon will lose bromine, and adjacent carbon, which could be this one or this one, will lose hydrogen to form a double bond on either side. So this is also incorrect. Third one is 3-bromopentane. In pentane we have 5 carbon atoms in the long chain, and on third carbon we have bromine. Again the molecular formula is same, C5H11Br, and elimination can occur. Bromine will be removed from this carbon and hydrogen can be removed from this adjacent carbon or this adjacent carbon to make a double bond on either side. So C is also wrong. Part D is bromo-dimethylpropane. In propane we have 3 carbon atoms in the long chain. We have bromo and dimethyl. It means bromine is attached with 1 carbon atom and 2 methyl groups are attached with other carbon atom. Now bromine is removed from this carbon and this carbon does not have any hydrogen atoms left for removal, so therefore double bond cannot be formed and elimination will not occur. Correct option is D. Question 26. The reactions of 4 organic compounds are given in the table. Which compound could be propane 2-ol? We have the reagent and observations. Reagent is oxidation with acidified dichromate to give an organic product with a boiling point greater than the original compound. And second one, the reagent is ethanoic acid and few drops of sulfuric acid to give sweet smelling compound. Now propane 2-ol is the one in which we have 3 carbon atoms, and as it is alcohol, so we have OH. Now this is secondary alcohol, and secondary alcohol can be oxidized in the presence of dichromate acidified to form ketone. Now in alcohol, oxygen, which is electronegative, is directly bonded to hydrogen atom, while in ketone oxygen is not directly bonded to any hydrogen atom, so therefore hydrogen bonding is absent in ketone. And due to absence of hydrogen bonding, boiling point of product should be lower than that of reactant. So we have a no. Second thing is addition of ethanoic acid. Now ethanoic acid is carboxylic acid and we have propane 2-ol as secondary alcohol. Now we know that alcohol along with carboxylic acid, they react together to form ester, and ester is a sweet smelling compound and it is a yes. Correct answer is therefore B. Question 27. Compound X has the empirical formula C2H3O. Compound X reacts with 2,4-DNPH to give an orange precipitate and also decolorizes warm acidified potassium manganate 7 solution. What could be the identity of X? Now from the test of 2,4-DNPH we can find out that compound X is either an aldehyde or a ketone, because only aldehyde or ketone can give orange precipitate with 2,4-DNPH. So in A we have aldehyde functional group on both sides, in B we have ketone functional group, in C we have carboxylic acid and alkene, in D we have carboxylic acid and aldehyde. So A, B and D can give positive result with 2,4-DNPH while C will not give positive result. Now second thing is the decolorization of acidified potassium manganate. It means compound X can be oxidized further as potassium manganate is oxidizing agent. Now ketone cannot be further oxidized, only aldehyde can be further oxidized into carboxylic acid. So A is aldehyde on both sides, it will be oxidized to carboxylic acid. In B we have ketone, so it will not be oxidized further. In C we have aldehyde, so it can be oxidized further to carboxylic acid. Let's find the molecular and empirical formulas. We have 4 carbon atoms in A, 6 hydrogen atoms and 2 oxygen atoms. So the empirical formula is C2H3O. It is similar to this one. In D we have 6 carbon atoms, 10 hydrogen atoms and 2 oxygen atoms. The empirical formula will be C3H5O. This is not similar, so therefore D is incorrect. Correct answer is therefore A. Question 28. Compound Y gives methanol and sodium ethanoate on treatment with aqueous sodium hydroxide. What is the structure of Y? Methanol is 1 carbon alcohol and sodium ethanoate is sodium salt of ethanoic acid. As the name of ester is from alcohol and ethanoate, so we have 1 carbon alcohol which is methanol, so it will be methyl, and 2 carbon ethanoate, so it is methyl ethanoate. The structure of methyl ethanoate can be drawn like this. We have 2 carbon, then oxygen and then CH3. So the structure similar to this one is given in part A. We have CH3, CO2 and CH3. Question 29. Which compound can be used to make propanoic acid by treatment with a single reagent? Propanoic acid is 3 carbon carboxylic acid, CH3, CH2, COOH. First one is alkene. Now alkene can be oxidized by a hot concentrated KMnO4. So this double bond will be broken down and this carbon is converted into carbon dioxide as this has 2 hydrogen atoms in it. So we can write the oxidation in the presence of acidified potassium manganate hot and concentrated. It will make CO2. And this carbon that is making a double bond is converted into carboxylic acid. So we have 3 carbon carboxylic acid that is formed. So this is propanoic acid and we have CO2. So A could be the correct option. In B we have CH3, CH2, CH2CN. This is a nitrile. Now nitrile can be converted into carboxylic acid. Upon acid hydrolysis we have water and acid presence. So As we have 4 carbon atoms on the reactant side, so 4 carbon atom carboxylic acid will be formed along with the salt of ammonium. If it is HCl, it will form ammonium chloride. 4 carbon carboxylic acid is called butanoic acid. It is not propanoic acid, so B is wrong. In third one, we have secondary alcohol and we also have nitrile. So CH3, CH, OH, CN. Again, nitrile can be hydrolyzed in the presence of acid. Dilute HCl to form CH3CH, and this carbon is converted into carboxylic acid. Now we have alcohol group and carboxylic acid, both functional groups are present, so therefore C is incorrect. Similarly in D we have CH3CH, secondary alcohol is present, CH3. It can be oxidized to form ketone. No carboxylic acid is formed, so therefore this is also incorrect. Correct answer is therefore A. Question 30. The IR spectrum of compound L is shown. We can see a broad peak between 3200 to 3600. This is because of the presence of alcohol functional group. And here we can see that carbonyl peak is absent. It means it is not an aldehyde or ketone or carboxylic acid or ester. Let's find out the structure. In A we have alcohol functional group. We also have ketone functional group. So as carbonyl peak is absent, so therefore A is incorrect. In B we have alcohol functional group. We have secondary alcohol. We also have aldehyde. In aldehyde, carbon is making a double bond with oxygen. So therefore as carbonyl peak is absent, so B is also incorrect. In part C we have alcohol functional group. No carbonyl carbon is present. So alcohol gives broad peak between 3200 to 3600 per centimeter, which is present in this structure, so therefore C could be the correct answer. In part D we have alcohol functional group. We also have carboxylic acid, which consists of carbonyl carbon. Now carbonyl peak is absent, so therefore D is wrong. Correct answer is therefore C. Question 31. Zinc reacts with hydrochloric acid according to the following equation. Metal plus acid gives salt and hydrogen. Which statements are correct? The molecular mass from periodic table we can find out. For zinc it is 65.4. For HCl hydrogen is 1, chlorine is 35.5, so it is 36.5. For zinc chloride it is 136.4. For hydrogen molecule it is 2. Part 1. A 3.27 grams sample of zinc reacts with an excess of hydrochloric acid to give 0.0500 moles of zinc chloride. Let's find out the number of moles from this mass, as moles is equal to mass in grams divided by molecular mass or atomic mass in this case. So 3.27 grams divided by 65.4 comes equal to 0.05 moles of zinc. As the ratio in balanced equation is 1:1 of zinc and zinc chloride, so therefore the number of moles should be similar, as it is 0.05 mole zinc and we also have 0.05 moles of zinc chloride, so therefore statement 1 is correct. Part 2. A 6.54 gram sample of zinc reacts completely with exactly 100 cm³ of 1 mole per decimeter cube hydrochloric acid. Again, we can find the number of moles of zinc by dividing mass with atomic mass. So 6.54 divided by 65.4 comes equal to 0.1 moles of zinc. Now from balanced equation we can see 1 mole of zinc requires 2 moles of hydrochloric acid. So therefore 0.1 mole of zinc should require 0.2 moles of hydrochloric acid. We are going to use the formula number of moles is equal to concentration in mole per decimeter cube into volume in decimeter cube. We can convert it into decimeter cube by dividing by 1000. So it is 0.1 decimeter cube. Now putting values, 1 into 0.1, it equals to 0.1 mole. According to the ratio, the moles of HCl should be double than the mole of zinc. So therefore it is not double, it is the same. So option 2 is wrong. Option 3. A 13.08 grams sample of zinc reacts with an excess of hydrochloric acid to give this volume of hydrogen measured at room conditions. Let's convert this mass of zinc into moles. Moles is equal to mass in grams divided by 65.4. So the moles come equal to 0.2 mole of zinc. Now the ratio between zinc and hydrogen is 1:1. It means that the moles of hydrogen should be the same as the moles of zinc. Let's find out the number of moles of hydrogen. Number of moles is equal to volume in decimeter cube divided by 24 decimeter cube. So it comes equal to 0.4 moles. As we can see that the number of moles are not equal, so therefore 3 is also incorrect. As only option 1 is correct, the answer is therefore D. Question 32. The melting point of chlorine is lower than the melting point of iodine. Which statements help to explain this difference? Now the melting point depends on the intermolecular forces of attraction, and intermolecular forces is directly proportional to the number of electrons present in the molecule. Option 1. Iodine has more electrons than chlorine. This is true, and so has stronger van der Waals forces. So greater the number of electrons, greater will be the intermolecular forces or the van der Waals forces. Part 2. An iodine molecule is more polar than a chlorine molecule. This is wrong because iodine molecule is made up of iodine. Electronegativity is same, so therefore no polarity is present. Similarly, chlorine molecule is made up of 2 chlorine atoms. As electronegativity is same, so therefore no pole is present. Option 3. The covalent bonds between iodine atoms are stronger than the covalent bonds between chlorine atoms. This is wrong because in chlorine the bond is more strong and more energy is required to break chlorine-chlorine bond as compared to iodine-iodine bond. As only option 1 is correct, the answer is D. Question 33. Aqueous iron to sulfate can take part in redox reactions. Which redox changes occur during this reaction? We have iron plus 2 and iron plus 3, chromium plus 6, chromium plus 3, oxygen and water. Let's find out the oxidation state. First one is iron sulfate. In the product we have iron sulfate. The charge on one sulfate is -2, overall charge is 0, so therefore iron is plus 2. Similarly, the charge on one sulfate is -2. We have 2 iron atoms, 3 sulfate, so for 3 it will be -6. Overall charge is 0. Therefore, the oxidation state of one iron is plus 3 in the product. So iron has been oxidized from plus 2 to plus 3. Now for chromium compound we have Na2Cr2O7 and Cr2SO4 3. We have 2 sodium, so the combined oxidation state will be +2. We have 2 chromium. For 1 oxygen it is -2, so for 7 it will be -14. Overall charge is 0. So 2 chromium minus 12 equals 0. For 1 chromium the oxidation state will be equal to +6. Similarly, in chromium sulfate, overall charge is 0. We have 2 chromium, 3 sulfate, so for 3 sulfate it will be -6. The oxidation state on 1 chromium is +3. So from +6 to +3 is reduction. Last one is oxygen. Oxygen is reduced to water. The oxidation state of oxygen in all these three is -2 for single oxygen. And in water the oxidation state is still -2. So 3 is incorrect. As option 1 and 2 are correct, the answer is therefore B. Question 34. The equation represents an equilibrium reaction. Ammonia reacts with oxygen to form nitrogen monoxide with water. The enthalpy change is -900, so it means it is exothermic reaction. What would increase the concentration of NO at equilibrium? NO is the product. Number 1, a reduction in the reaction temperature. This is true because when temperature is reduced for exothermic reaction, the equilibrium moves in the forward direction and more product will be formed. Part 2, the use of suitable catalyst. Now catalyst only decreases the activation energy and the rate of reaction is increased in both forward and backward direction. The concentration of any reactant and product is not affected. Part 3, an increase in total pressure. Now pressure depends on the number of moles. We have 5 and 4, 9 moles on the reactant side and 10 moles on the product side. So when pressure is increased, the reaction will move from more number of moles to less number of moles, so the concentration of product will decrease. As only option 1 is correct, the answer is D. Question 35. A sample containing X moles of aluminum chloride is dissolved in water to give solution W. In order to precipitate all of aluminum as its hydroxide, Y moles of sodium hydroxide are required. More of the alkali is added to redissolve the precipitate, giving solution Z. Which statements are correct? Now X moles of aluminum chloride is dissolved in water to give solution W. We can write this as Al2Cl6. When it is dissolved in water, it forms aluminum +3 and chloride -1. Now what happens with aluminum +3 is that it is surrounded by water molecules. Aluminum is surrounded by 6 water molecules. Overall charge is +3 of this complex ion. Now proton is lost from one of the water. So now we have AlH2O5. One of the water molecule has lost H+, so then OH is left behind. And the charge now becomes +2 along with H positive ion. Now this produces H positive ion, which means the solution will now become acidic. This is solution W. Number 1, the initial pH of solution W is below 7. As we can see that the solution is acidic, so the pH must be below 7, so statement 1 is true. Second thing is the dissolution of precipitate of aluminum by adding sodium hydroxide, so we can write the chemical equation. Aluminum chloride plus sodium hydroxide. It forms aluminum hydroxide along with sodium chloride. Let's balance this equation. We have 2 aluminum atoms on the reactant side, so we can balance 2. We have 6 chlorine atoms, so we can write 6 with NaCl. Now we have 6 sodium, so we can write 6 with Na. Oxygen and hydrogen are already balanced. Now in balanced equation we have 1 mole of aluminum chloride, which is X. So X equals 1. We have 6 moles of sodium hydroxide, which is Y. So Y equals 6 moles. So we can say that 2 is wrong because 6 does not equal to 3 into 1. Part 3, Z contains X moles of aluminum. Now solution Z is formed by adding alkali to dissolve the precipitate. This is the precipitate that is dissolved in excess alkali. In this precipitate we have 2 moles of aluminum. So Z is equal to 2. When it is compared with X, it is not equal to X as X is 1. So Z is equal to 2 into X. C does not contain X moles, it contains 2 X moles of aluminum. As only option 1 is correct, the answer is D. Question 36. Which statements concerning calcium hydroxide are correct? Number 1. It is less soluble in water than strontium hydroxide. Now this is true statement because solubility of group 2 hydroxide increase down the group. Part 2. When it is added to water, an alkaline solution is formed. Calcium hydroxide, when added to water, it forms calcium plus 2 and hydroxide negative. So therefore this is alkaline solution. This solution is used to reduce the acidity of soil. Part 3. It is used in agriculture to lower soil pH. Now it is used in agriculture to increase the pH of soil. It cannot lower the pH of soil because it is alkaline in nature. Option 1 and 2 both are correct. The answer is B. Question 37. Which bromopropenes would react with cold bromine in the dark to form a product containing a chiral carbon atom? For alkenes, addition reaction takes place with bromine. So first one is CH double bond CHBr. Upon addition of bromine, what will happen? That double bond is converted into single bond. And one bromine atom is added to first carbon while second bromine is added to second carbon. Now chiral carbon is that carbon that has 4 different elements or groups attached with itself directly. So we can see this carbon, it is bonded to one hydrogen, one bromine, one CH3 and one this. So therefore this is chiral carbon. Second one is CH2 double bond CH and we have CH2Br. Now again addition of bromine will take place. Double bond is converted into single covalent bond. On both carbon atoms bromine are attached. Now we can see that with this carbon atom, this and this is similar, so therefore this is not chiral. For third one, we again have CH2 double bond, then we have carbon, bromine and CH3. Now double bond is converted into single bond. And each bromine atom is attached to each carbon atom having double bond. Now we can see that this carbon atom is bonded to 2 similar atoms and this carbon is bonded to 2 similar hydrogen atoms, so none of the carbon is chiral. Option 1 is correct, answer is D. Question 38. Halogenoalkanes can undergo reaction with hydroxide ions. Halogen is replaced by OH to form alcohol and halide ion. The reactions of some halogenoalkanes proceeds by SN1 mechanism. Which statement about SN1 mechanism are correct. Number 1, a carbocation is formed which is stabilized by the inductive effect of the alkyl groups present. Now this is true for tertiary halogenoalkanes. In tertiary halogenoalkanes, the carbon atom having halogen is attached to 3 carbon atoms directly. Now what happens? First, carbocation is formed. And in heterolytic fission, bromine atom is lost. Now this carbocation is stabilized by these methyl groups, as methyl groups have positive inductive effect by which they donate their electrons to this carbocation to make it stable. So statement 1 is correct. Part 2, only tertiary halogenoalkanes are hydrolyzed in this way. Now tertiary halogenoalkanes always take SN1 mechanism, while secondary halogenoalkanes can go through SN1 as well as SN2. Option 3, the intermediate formed includes a carbon atom with 5 bonds attached to it. In tertiary halogenoalkanes this is not true, but in primary halogenoalkanes this is true, as SN1 is of tertiary halogenoalkane, so this is wrong. Option 1 is correct, the answer is D. Question 39. Which statements about 2-methyl-butane 1-ol are correct? Number 1, it can give HCl gas on reaction with PCl5. Now let's write 2-methyl-butane 1-ol. In butane we have 4 carbon atoms. 1-ol means that OH is attached on the first carbon atom, and on second carbon atom methyl group is attached. Rest are the hydrogen atoms. Upon reaction with PCl5 at room temperature, what happens is that OH is replaced by Cl, along with POCl3 and HCl. So HCl gas is formed in this reaction, so statement 1 is correct. Number 2, it can be oxidized to give an aldehyde, as we have primary alcohol, and primary alcohol can be oxidized to form aldehyde. The product will be like this. Statement 2 is correct. Number 3, it displays optical isomerism. Now for optical isomerism, chiral carbon should be present. Chiral carbon is the one having 4 different elements and groups directly attached. We can see this carbon is attached to 1 hydrogen, 1 CH3, 1 CH2OH and 1 CH2CH3. So this is chiral carbon and it will display optical isomerism. All 3 options are correct. Answer is A. Question 40. The compound cis-hex3-enyl is responsible for characteristic smell of cut grass. We have alkene functional group. We also have aldehyde functional group. Which reagents will react with cis-hex3-enyl? First one is sodium. Sodium does not react with alkene or aldehyde. So it is incorrect. Second is sodium borohydride, which is NaBH4, and it is a reducing agent. It can reduce aldehyde back to primary alcohol. So this compound will be reduced to CH3, CH2, CH, double bond CH, then we have CH2, then this carbon, COH. Third one is Phalens reagent. Now Phalens reagent can react with aldehyde to give positive result.
It does not react with alkene, so therefore as aldehyde is present, so Phelan's reagent will give positive result. As option 2 and 3 are correct, answer is C. Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.